In this video, I'm going to show you how to factor basic quadratic expressions using 3 different methods. The first method is technically it is a method in and of itself, but it's also something that you just always want to check for. It's known as the GCF, or greatest common factor method, because anytime you are trying to factor any kind of algebraic expression, you first want to see if there are any numbers that can be factored out or any variables that can be factored out. And so in this example right here, both 5 and 30 have a common factor that I could take out of 5. Now, a good rule of thumb is that your greatest common factor should never be more than any one of your single numbers. It can be equal to one of the numbers, like it is here, but it should never be larger than any one of the numbers. And then I also look at the variables, and I see, well, this has x to the second, and this has x. So I can take an x out of both of them. Again, you see here the greatest common factor between the variables is never more than any one of the terms itself. It can be one of the variable terms, but it can't be more than that. So the greatest common factor here would be 5x, and I would write it out front in front of parentheses because I am factoring it out. And then in the parentheses, I'll just put what gets left behind. And you can see that 5 divided by 5, that makes 1 whole. And x squared divided by x leaves me with just 1x. So I write just x. Then over here, a 30 divided by 5 makes 6, and it's still going to be positive, so plus 6. But x divided by x makes 1 whole, and 6 times 1 whole doesn't really change it. So x plus 6 is what gets left behind, and that would be my final answer in this case, because the greatest common factor is all that I could really take out of this expression. All right, next example. Again, I always want to check for a GCF first. I look at the numbers and I see 8 and 2. Well, 2 can obviously come out of itself, and 2 can also come out of 8. I also have a common factor of x that can come out of both of them. And so 2x is what I have factored out in front of the parentheses, and left behind I would have 8 divided by 2, which gives me 4, and x squared divided by x leaves me with 4x. Then over here you'd see that 2 divided by 2 makes 1 whole. X divided by x also makes 1 whole. And so it looks like the whole term cancels, but remember, in this sense, when we say it cancels because it makes 1 whole. So I still have to write minus 1 whole, and then I close the parentheses. And again, in taking out the greatest common factor here, that is the complete factorization of that algebraic expression. Sometimes we can look at an algebraic expression and we might look at the numbers like 4 and 9, and we might say, well, there is no common factor between those. But don't forget, you also need to check the variables. In this case, I do have a common factor of x that I can take out, and that is meaningful. So I take out the factor of x, and left behind I would now have a 4x plus 9. So even when all you can take out is one little variable term, that is still important to do, and this would be what your final answer would look like there. All right, the next method that we're going to look at is factoring what we call a quadratic trinomial. And this first method is when the quadratic trinomial has a leading coefficient. In other words, the coefficient on the x squared term, it looks like there isn't one, but that's because it's actually that invisible 1. Now, obviously, you would want to check for a greatest common factor, but you'd see here 1 and -5 and 6, they don't have a common factor. X squared, x, and no x's at all, they don't have a common factor. So there is no GCF here, but I do want to check. That leads me into this new method that is going to be factoring when the leading coefficient is 1. The steps for doing this is the trinomial is always going to break down to be the product of 2 smaller binomials, and you'd put each one in parentheses. So you can start by drawing them. Then the x squared part, you can think of it as factoring to be x times x. That's the only way that x squared would factor. So you can go ahead and fill in your variables here. And then to come up with the rest of this part, we're going to do what I call a little X game. You come over here, and the last number in the expression, we call it the C term. it is going to be, and it's positive, it is going to be what goes in the top of our little x game. And then this middle number that's multiplied by just x, we call it the b term, and it's -5 in this case. It goes in the bottom of our x game. Now the whole goal of this game is to find two numbers that can go here and here that would both multiply to make a +6, but also add to make a -5. What I suggest is start out with the number they're supposed to multiply to make, and just list out any factors that you know for that number, which isn't too hard in this case because there's only two pairs. Then you might be thinking, well, how am I going to multiply two numbers to make a positive but add them to make a negative? There's a really easy little chart that you can use to help you with this. You first look at the sign on your C term, and then look at the sign on your B term. Because if the C term in the expression is positive, that means the signs on your factors will be the same. They'll either both be positive or they'll both be negative. If the sign on C is negative, that tells us that the signs on the factors we're looking for are going to be different. One will be positive and one will be negative. So look at C first, then look at B. If C is positive and B is positive, that means both of your factors will be positive. If C is positive but B is negative, that just means both of your factors will be negative. Over here, if C is if C is negative but B is positive, that means the larger of the two numbers in your factor pair would be positive, and if C is negative and B is negative, that means the larger of your two factors would be negative. So using this little chart can really help with knowing what signs to put on your possible factors. So in this case, C was positive, so I'm looking over here. B was negative, so C positive, B negative. Both of our factors will need to be negative. So in this list that I just made, both of the possible factor pairs would need to be negative, and now I could just check to see -1 minus 6, that makes -7, not what we want. -2 plus -3, that makes -5, which is what we want. So that tells us that these are the two numbers that work for our little x game here. They are the winners. But more importantly now, these are the two numbers that we're going to drop into these parentheses over here. So it'll say x minus 2 and x minus 3. And this gives us the two factors that the quadratic trinomial we started with would break down to be. And always, 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 when you factor, you can check your work by redistributing the two factor pairs that you found to see if you get what you originally started with. So if I did that here, I would first do x times x, which gives me x squared. I'd also do x times -3, that gives me -3x. Now I need to distribute -2 times x to make -2x, and -2 times -3 makes +6. Now it doesn't look exactly like what we started with, but that's because there's a pair of like terms that I can combine, and if I do, I get x squared minus 5x plus 6, and that is what we started with back up here, and so that helps me know that this is the correct factor pair for that quadratic trinomial. Now sometimes we have a quadratic trinomial, but you'll see that the leading coefficient in this case is not 1. There is a number that we see here, and in this case it's 2. Always, always, always check to see if you've got a greatest common factor, because if so, you want to take it out, and if there is a greatest common factor, what you're left with might be simpler to work with. If I look here though, I've got a 2, a -3, and a -9. No common factor for them. I've got an x squared, an x, and then no x's, so there's no common factor for them. So I checked for the greatest common factor, but there wasn't one, and so that means we're left with trying to factor a trinomial where the leading coefficient isn't 1. We can use a similar kind of method to the last example. It's still going to factor to be things in two sets of parentheses, and we can even still use our little x game, but here's the big difference. We don't just put the last number up here. We put this number, which we call our a term, And this number, which again, remember we call that our C term, you multiply A times C, and that's what you put up here. So in this case, a 2 times a negative 9 gives us a negative 18. Now on the bottom, you still put this middle term. Remember we called it B, and so in this case, negative 3 is what goes in the bottom. So remember, we're trying to find two numbers that would multiply to make a negative 18, but would add to make a negative 3. I'm just going to start by listing factor pairs that I know for 18, starting with the obvious one, 1 and 18, 2 and 9, 3 and 6. 4 doesn't factor with 18, 5 doesn't either, and 6 is where it wraps back around. So this is all of my factors. Now again, note that there's got to be something going on with negatives here, but I don't know what, and so I'm going to refer back to this little chart that I told you about in the last slide. First, I look at the sign on C, because if the sign on C is positive, then the factor pairs will have the same sign, where if the sign on C is negative, the factor pairs will be different signs. In this case, C is negative, so that means our signs will be different. Then look at the sign on B, because if C is negative but B is positive, the larger of the two factors will be positive, whereas if C is negative and B is negative, the larger of the two factors is the negative one. So in this case, C is negative and B is negative. That means the larger of our factors would be the negative one. That means it'd be 18 or 9 or 6. And then you just add these pairs up until you find the one that gives you negative 3, which I think it would be 3 minus 6, that gives us the negative 3. So here's our two winning numbers, a positive 3 and a negative 6. And so these are the two numbers that will go in the parentheses over here with our variable, which we break down to be as x and x. And this would say x plus 3, x minus 6. Now in the last example we were done here, but notice if I stopped here, it looks like x times x, that's not going to make 2x squared. So the last new part of this, when a is not 1 method, is whatever this number is right here. If it's not 1, then what you do is you do what we call you slide and divide. And so I'll show you what that looks like. You literally take the number that's right here and you slide it under these two factors that you came up with, and then you divide. Now usually one will divide evenly and the other will not. And so in this case, 3 does not divide by 2. However, 3 over 2 is a reduced fraction. So what I do is I move this denominator that doesn't simplify to the front, making this factor now 2x plus 3. And over here, notice 6 does divide by 2. That just makes 3. So this factor would be x minus 3. Now I'm done. These are the correct factors that I needed, and you can double check by multiplying everything back out, but at the very least notice that 2x times x does make 2x squared like it should. So without necessarily needing to multiply the whole thing back out, I can say I feel pretty confident about those two factor pairs. All right, one more example. Again, it's a quadratic trinomial. The very first thing I want to do is check for a greatest common factor. If I look at 6 and 33 and 15, there actually is a common factor between them. It is 3. There's no common variable factor because these both have some x's, but this one does not. So the 3 is really all I can take out. But I will take it out, and that leaves me with 2x squared plus 11x plus 5. Now notice the quadratic trinomial I'm left with is at least a little bit simpler in that the numbers are smaller. And so I can factor this. Note that the leading coefficient here is larger than 1, so we'll use the method that we did last time where we know it's going to factor to be two sets of parentheses. We're going to use our little x game. We're going to multiply a times c to get the top number. In this case, it's positive 10. And we use b as the bottom number, so in this case, it's 11. And we notice that both c and b are positive, and so that means that both of our factor pairs will be positive. And so we come over here and list out the factors we know for 10, which there's only 2 of them. And we see 2 plus 5 doesn't make 11, but 1 plus 10 does make 11. So a positive 1 and a positive 10 go here. And over here, x squared breaks down to be x and x. We fill in now the plus 1 and the plus 10, but we're not done because is there a number here to slide and divide? Yes, and so we slide it under. And again, we see 1 divides evenly. That would make x plus 5. The other doesn't divide evenly, but it is a reduced fraction, and so we move that unsimplified denominator to the front, making this one a 2x plus 1. Now we want to keep that 3 that we factored out from the very beginning out front just to show that we did take care of it, we didn't lose it. However, these are the factors that we're left with from that trinomial. And you can see again that 2x times x would make 2x squared, and so without necessarily multiplying the whole thing back out, I can say that I feel pretty confident about this factorization. So that's a really basic and quick rundown of the first 3 methods that we looked at in analytic geometry for factoring. Hope this was helpful, and please feel free to watch it again if you need to.